For this problem, these are like bowls cut out of the cylinder. So if this is one solid cylinder, then you dug out a bowl, something you can almost like skate in, but both on the top and the bottom. So in this bowl, you could dive in from the, dip in, drop in from the top, or if you were defying gravity, you could drop in from the bottom into the bowl. All right, so the volume of this shape will be the entire cylinder and then minus, carve out, subtract the volume of those bowls. Well, two bowls together is two half spheres. So when we subtract this half sphere and this half sphere of volume, we're really subtracting a whole sphere. So the volume of this composite is the volume of the entire cylinder, pardon my bad drawing, minus the volume of an entire sphere. All right, what's the radius of the circular base of the cylinder? 3. What's the radius of the entire sphere if we put these two half spheres together? 3. Pi r squared for the area of this base, and the radius was 3, and the height, which is 7. And for the sphere, pi r cubed, 4/3 pi r cubed, and the radius there is 3. Remember, the height isn't 6. The height isn't always up and down. The height is always the distance from one base to the other base, which in this case is 7. So we can wrap this problem up. The volume of this composite figure is 63 pi minus 36 pi, or in other words, exactly 27 pi, or approximately 84.8 cubic feet are the units. All right, I hope that helped. And at the very least, you had to love this drawing. It's pretty bad, but sometimes it's what makes things bad that makes them lovable. Even people. 'Tis our foibles that make us lovable. Somebody said that. I forget who said that. I don't know. Plato? Socrates? I don't know.